India has inducted its third indigenously developed nuclear-powered submarine, INS Aridhaman, marking another significant milestone in the country's strategic deterrence program. The name Aridhaman, which translates to Vanquisher of Foes or Slayer of Enemies, reflects the platform's role within India's nuclear deterrent architecture. Speaking at the commissioning ceremony, Defense Minister Rajnath Singh described the significance of the submarine, stating that Aridhaman is not merely a name, but a symbol of power, highlighting its importance in enhancing India's strategic strength. In this video, Defense Updates analyzes why INS Aridhaman is a major boast for India's nuclear deterrence. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. INS Aridhaman represents the next evolutionary step in India's sea-based nuclear deterrent, reinforcing the country's ambition to maintain a credible and survivable second strike capability. It is the third submarine in the Arihant-class submarine series. Developed under India's Classified Advanced Technology Vessel (ATV) program, the submarine reflects a maturing indigenous capability in nuclear submarine design and construction. The project is spearheaded by the Indian Navy, with critical technological inputs from the Defense Research and Development Organization and the Department of Atomic Energy. Built at the Shipbuilding Center in Visakhapatnam, the submarine class is a product of sustained domestic expertise, though early technological collaboration with Russia continues to underpin aspects of reactor and propulsion design. Aridhaman is an evolution over its predecessor, INS Aridhaman, incorporating incremental improvements in reactor efficiency, acoustic quieting, and missile integration. The submarine displaces around 7,000 tons. It has a length of 365 feet, 130 meters. The boat has one 7-blade propeller powered by a compact light water reactor, CLWR. It can achieve a maximum speed of 28 kilometers per hour, 17.5 miles per hour, when on surface and 44 kilometers per hour, 27 miles per hour, when submerged. The CLWR is an upgraded form of the one that powers INS Aridhaman and generates around 83 megawatts. This has significantly lower acoustic signature than the previous generation, making it harder to detect by enemy vessels. INS Aridhaman is thought to be able to operate at depths of 1,300 feet or 350 meters. The submarine has USHUs and Panchendria sonars for situational awareness. INS Aridhaman represents a significant advancement in India's sea-based deterrent capability, particularly in terms of missile payload capacity. The submarine is equipped with 8 vertical launch system (VLS) cells, capable of carrying either 8 K4 missiles, 1 per tube, or 24 K15 Sagarika missiles, 3 per tube. This marks a substantial improvement over its predecessor, which was limited to 4 launch tubes, effectively doubling the platform's strike potential and operational flexibility. The K4 SLBM, often referred to as Kalam 4 and associated with APJ Abdul Kalam, is a nuclear-capable, intermediate-range ballistic missile developed by the Defense Research and Development Organization specifically for deployment aboard Arihant-class submarine. The missile is a 2-stage, solid-fueled system measuring approximately 12 meters in length with a diameter of 1.3 meters and a launch weight of around 17 tons. It is capable of carrying a nuclear warhead of up to 2 tons and has a reported range of approximately 3,500 kilometers, or around 2,175 kilometers. This extended reach enables India to hold strategic targets at risk deep within adversary territory, particularly in China, while operating from relatively secure maritime zones. A key technological feature of the K4 is its underwater launch mechanism. The missile employs a gas generator system that produces a high-pressure gas bubble around the missile during launch. This bubble reduces hydrodynamic drag as the missile transitions through water, allowing it to breach the surface efficiently before igniting its main rocket stages for atmospheric ascent. The missile is further stabilized and guided by 4 control surfaces at its base, ensuring aerodynamic control post-launch. Additionally, the K-4 is believed to possess advanced maneuvering capabilities, enabling it to execute 3-dimensional evasive trajectories as a countermeasure against ballistic missile defense (BMD) systems. In terms of guidance and accuracy, the K-4 utilizes an inertial navigation system, INS, augmented by satellite-based inputs such as GPS or India's NAVIC. This combination reportedly allows for a high degree of precision, with estimates suggesting a circular error, probable CEP, of less than 10 meters, an exceptionally accurate figure for a ballistic missile of this class. By contrast, the K-15 Sagarika is a shorter-range, nuclear-capable SLBM with an approximate range of 750 kilometers or 466 miles, powered by a 2-stage solid propulsion system. In strategic terms, the K-15 is optimized for regional deterrence, primarily addressing threats from Pakistan, while the longer-range K-4 extends India's deterrence envelope toward more distant adversaries such as China. Together, these missile systems provide INS Aridhaman with a versatile and layered strike capability, significantly enhancing the credibility and depth of India's sea-based nuclear deterrent. India is among a select group of nations that possess an operational nuclear triad, the capability to deliver nuclear weapons from land, sea, and air. This triad comprises land-based intercontinental ballistic missiles, such as the Agni series, deployed from both fixed silos and mobile launchers, air-delivered nuclear capability via platforms like the Dassault Rafale, and sea-based deterrence provided by Arihant-class submarine armed with K-series SLBM. Among these, ballistic missile submarines constitute the most survivable and resilient leg of the triad. In the event of a nuclear first strike, an adversary may be able to target and degrade land-based missile infrastructure and air bases hosting nuclear-capable aircraft. However, SSBNs operating silently in the depths of the ocean are exceptionally difficult to detect, track, and neutralize. Their stealth, mobility, and endurance ensure that a portion of the nuclear arsenal remains secure and capable of retaliation, thereby underpinning a credible second strike capability and reinforcing overall deterrent stability. The induction of INS Aridhaman into service, alongside INS Arihant and INS Arigat, marks a decisive step toward establishing continuous at-sea deterrence, a benchmark achieved by only a handful of nuclear powers. With a minimum of 3 SSBNs in rotation, India gains the operational flexibility to ensure that at least one submarine remains on deterrent patrol at all times, while the others undergo maintenance, replenishment, crew training, or refit cycles. This rotational model eliminates predictable gaps in deployment, thereby removing any potential window of vulnerability that adversaries could exploit. More importantly, it guarantees a persistent, survivable nuclear presence at sea, where submarines remain concealed and largely invulnerable to preemptive strikes. In strategic terms, continuous at-sea deterrence significantly enhances deterrence credibility by ensuring that India's second strike capability is not only intact but continuously available, reinforcing stability in a nuclearized environment.